Hi, doctor. Today I'm going to present our assignment 2, which is about classification using the supervised and unsupervised learning approaches. So our group member have Qi Yuan, me, Kai Xiang, Roshini, and Xiula. So we have give everything that our file in this GitHub for total reference, but we also will attach our source code or implementation file into our assignment. So this is Sula and this is me and this is Roshini and this is Qiyuan. So basically this task distribution is we are the first step we are to prepare the data. Therefore our models training. So this part will be prepared by the Qiyuan. And the part A, which is supervised training, mainly will be prepared by Sula and me. Then the next part B will be prepared by Qiyuan and Roshini. Then in the end, we'll do a summarization about the real case implementation. So this part will be done by Sila and Jian, and summary will be me, and also the video presentation also will be me. So the first step we start our assignment. This should be all typical step. So the first step should be the data preparation, which is data mining. So the first step we will extract the data first. So we decide to classify articles into 4 categories. So which is healthcare, AI, IoT, and blockchain. So we search the article and manually mine the data to avoid complication due to the permission issue in different websites. So the next step we will do the data summarization. So due to the article is quite lengthy, so the per embedding size is just 768 tokens. So next, the long article are broken down into multiple groups where text ranging is between 250 to 500. So GPT is used to enhance and summarize the context after the text streaming. So after this done is part, so we are come to the next step, which is data pre-processing. So basically just want to standardize the text like the punctuation, removal, and etc. So next step will be the BRT context embedding. So this pre-processed text are fed into the BRT to be transformed into context rich to be set into our custom dataset. So at this step, the self-built dataset is ready. So the next step we are do the exploratory data analysis. So the BRT result in 668 data points tokens. So these 168 data point tokens are considered quite small. However, it is still difficult to visualize the evidence. Thus, PCA is used to reduce the data point to 2. So this is our principal component analysis. So the dataset is ready to use. So we come to our part A, which is supervised learning models. So we will use 4 models in this supervised learning with KNN, decision tree, random forest, and SVM. So this is basically after we run our models, the result in 4 different models in the way of confusion matrix. So this is also the performance of different kind of approach, supervised approach. This accuracy, then this is our classifiers. So to summarize for the KNN decision tree, so this is our so-called each category and overall performance. So so to compare the KNN decision tree, so generally the KNN classifier is outperform the decision trees, especially in breeding IoT this category. So for decision tree classifier, generally it performs purely in breeding IoT instances compared to other categories. So the next is the random forest and SVM. So basically you can see the random forest classifier is show the strong and balanced performance across all the categories. Even so far is you can see this is the best, but actually the best of the best is our SVM, which achieved the perfect or near perfect scores across all the categories, indicating the excellent performance. So we have come a conclusion that amongst these 4 models, have concluded that SVM classified as stand out with consistently high precision, recall, and F1 score across all categories, indicating the robust performance. So the challenge is that the decision tree classifier struggles notably in breeding the IoT this intercept with low precision, recall, and F1 score in this category. So consideration depending on the specific application and priority of the metrics, which is precision, recall, and balance F1 score. So it the choice of classifier may vary. So generally we still recommend SVN is recommended for overall balanced performance, while KNN is noted for its strength in certain categories like IoT prediction. Random forest also showed a strong performance across categories but is slightly less than the SVM in the precision recall balance. So I will move to the next, our unsupervised learning models. So this is our unsupervised learning model methods. So we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. So we have M models, k-means, hierarchical, and mean shift DB scan. So this is our DB scan clustering and the mean shift clustering. So basically both these algorithms are not suitable for classification for this task. So PCA couldn't help on this situation. So the next is we will show a summary table for our old models, and this is our so-called performance metrics, and these are our different models of performance. So this is the plot for k-means clustering and the Chihote coefficient, and these are for hierarchical agglomerative clustering. So we come to our comparison for this unsupervised learning. So we analyze of each clustering algorithm. For k-means clustering, the strength is it had a high score for this and indicating a well-defined cluster. But the winners is he had a high Davis Bording index. So which is suggesting the length is distant cluster. Then the k-means clustering with PCA have the highest Chihote score and a good adjusted rank index. But the winner is he just get a moderate Davis Bording index. And the next is the hierarchy agglomerative clustering. So we have a high accuracy and cluster purity, but have a lower score of this and moderate. And the last one is the hierarchical agglomerative clustering with PCA. So this one have a high accuracy, good Chihote score, and a cluster purity. And the winner is high Davis index. So come to conclusion for unsupervised learning. Evaluating the clustering algorithm based on our provided matrix, which is the k-means clustering with PCA, emerged as the best among our existing models. So it provides a good balance across these so-called key metrics. This is which is the highest Chihote score with moderate Davis Bording index, highest adjusted rank index, high accuracy, and high cluster probability. So you can see generally all of these metrics the performance is from high to highest. Yeah. So but only one is get a moderate. So it indicates that supervisor still has a poorer performance as compared to our supervised learning in classifying particles with defined clusters. So we have real case classification using SVM. So in this case study, so SVM still is the best for the classification. So SVM is able to predict the class of particles like I mentioned to Dr. just now, which is healthcare, AI, IoT, and blockchain accurately. However, there's still a chance that SVM still can be able to wrongly classify between AI and IoT. Simple reason is due to the closely related domain. So this AI and IoT is quite related to each other. The relationship is quite strong. So it's understandable that our SVM is sometimes have a wrongly classified. So beside that, Data loss happen during the text streaming and article text grouping into smaller due to eventing constraint. So we have some technical problem also we are causing the SVM less accurately, so-called less accurate. So an approach to mitigate the error is to get the average class prediction. For example, an AI article text is broken down into 10 groups, then the 10 group could be have a different prediction, but most of the prediction is still biased toward AI. By averaging the score, so actually by using this way, the actual prediction cluster can be attained. So we come to our this assignment conclusion by comparing the supervised learning to the unsupervised learning in our article classification task. So we have come to a conclusion that supervised learning still comparing to the is use the label data to train the models that can be categorized article into predefined classes. And then the supervised learning cluster is article is into group with similar context without labels. Thus, in this by this conclusion, we can know that actually supervised learning can achieve better result in this assignment. However, unsupervised learning still useful in clustering larger amount of unlabeled data into group for future post-processing process. So that's all from me, Doctor. Thank you.